Now let's see the types of schedules. So one type of schedule is serial schedule. So what is a serial schedule is, if we don't have any interleaving, then generally that type of schedules is called serial schedules. The meaning of this is, if you have started a transaction, just finish it off till the end without going to other transaction in the middle. If you are going to do that, then such type of schedules are called as serial schedules. And next one is, when transactions are executing serially, that always ensures the consistency. So this means that when you make sure that all the transactions are going to execute one after the other, then the database is going to be consistent. Consistent means it is correct. So always serial schedules are going to give you correct answers. But then it doesn't mean that all the non-serial schedules will give you inconsistent states. No. So there can also be some non-serial schedules which might give you correct results, which means consistent states, but it is difficult to find them out, or you are supposed to find them out, right? Find out all the non-serial schedules which are equivalent to these serial schedules and execute them. That is the main purpose of this entire theory. And the next one is, if there are n transactions in a schedule, the possible number of serial schedules are n factorial. This is what we have seen. Okay. Now let's see an example. Assume that we have two transactions, then how many serial schedules are possible, and then let's see what are the examples. Assume that two transactions are like this, T1 and T2. Now this is a schedule in which I am finishing T1 first and then I am starting T2. So I am finishing T1 first and then I am starting T2, right? And again, this is the example of a schedule where I am finishing T2 first and then I am starting T1, right? So if both of these, since there is no interleaving, which means once I start it I am going till the end and then only I am going to the next one. Since there is no interleaving between the transactions, you can call it as serial schedule. This is the example of serial schedule. Now what about non-serial schedule? Whenever, see this, you have started this T1 and you have executed till this point, and then again you are going to T2 without completing it, right? So there is interleaving. Now whenever you have such interleaving, then it is called as non-serial, right? And in this case, this non-serial schedule is going to be inconsistent, right? So if you observe it, it is going to be a lost update problem, isn't it? But then I am not saying that all the non-serial schedules are going to create problem. No, there can be some non-serial schedules which might work well, right? But in this case, that is an example of a non-serial schedule which is not working well, right? But anyway, here we want to see what are the examples of serial schedules, and these are the examples of serial schedules. Only two are possible. Got it? Okay.